In the previous class, we discussed about the classification of ethers and the nomenclature of ethers. We are discussed in the previous class. In this class, we are going to be discussing about the preparation of ethers. That is preparation of ethers done by using the different methods. Ethers. That is the first method which is used to prepare the ethers is by dehydration of the alcohols. That is the first method we are going to be used that is by dehydration. Dehydration of alcohols. In this method, by the dehydration of alcohols means when the primary alcohols like ethyl alcohol is going to be heated with the concentrated sulfuric acid at 413 Kelvin. What we are going to be do? That is primary alcohol like that ethyl alcohol is going to be heated with the concentrated sulfuric acid. Why we are using the concentrated sulfuric acid? Because it is a dehydrating agent. Therefore, that is the primary alcohols like that is the ethyl alcohol is going to be heated with that is a dehydrating agent like that is concentrated sulfuric acid at 413 Kelvin. It is going to be formed that ether. That we are going to be done. That is ethyl alcohol, that is C2H5OH. That is 2 molecules of ethyl alcohol undergoes the dehydration in the presence of concentrated H2SO4. In the presence of concentrated H2SO4 and under 413 Kelvin. At that time, it undergoes the dehydration. It is going to be formed that ether C2H5O, diethyl ether. Diethyl ether plus H2O means dehydration is that is the removal of water. This we are going to be studied by using the mechanism. That is the mechanism we are going to be done in the 3 steps. Mechanism of the above reaction. The mechanism of this reaction which undergoes in the 3 steps. First, in the first step, what will happen? It is going to be formation of the protonated alcohol. It is going to be formed the protonated alcohol. In the second step, this protonated alcohol is going to be combined with an unprotonated alcohol to form an oxonium ion. In the third step, in the oxonium ion, loss of the proton to form an ether. Means this reaction mechanism can be explained in the 3 steps. The first step is that is the formation of the protonated alcohol. In the second step, that is the formation, in simple words we can say that the formation of oxonium ion. In the third step, we can say that loss of the proton from the oxonium ion. This we will study one by one step now. That is in the first step, we are going to be taken the step 1. Step 1 we are going to be taken. That is the first step, what happens? That is the formation of protonated alcohol. That is the first step, formation of protonated alcohol. Protonated alcohol means the alcohol C2H5OH. That is proton. It attacks the proton. Then the formation of that is the protonated alcohol. That is C2H5OH plus. That is the formation of protonated alcohol. In the step 2, when it comes to that step 2, that is an unprotonated alcohol combines with protonated molecule to form oxonium ion. In this unprotonated alcohol means we are going to be taken that C2H5OH. This we call as a unprotonated alcohol. This is going to be combines with the protonated alcohol. This which undergoes the removal of the water molecule. Removal of the water molecule. Then we are going to get the C2H5O, C2H5. This we called as an oxonium ion plus H2. In the third step, what is going to happen? In the third step is going to be loss of the proton from the oxonium ion. That is C2H5OH, C2H5 plus. This is the loss of the proton. It is going to be formed as C2H5O, C2H5. Diethyl ether. It is going to be formed. Then plus H plus. This is the step 3. The step 3, we can say that loss of proton. This we call as third step. This is about the mechanism of this dehydration of alcohols in the formation of the ethers. That is in the first step, the formation of the protonated alcohol is going to be formed. In the second step, an unprotonated alcohol is going to be combined with the protonated alcohol to form an oxonium ion in the second step. In the third step, it's going to be losses the proton from the oxonium ion to form an ether. This we call as diethyl ether. This is about the mechanism of this reaction. The next, another important reaction we are going to be studying, that is Williamson's ether synthesis. This Williamson's ether synthesis is a very important named reaction. This reaction asked so many times in the board examination. That is, we are going to be studying now. That is Williamson ether synthesis we are going to be studying now. That is another important second one. That is Williamson's ether synthesis. This is an important question for the board examination. So many times asked in the board examination for the 1 month. Okay, 1 month and 2 months so many times asked in the examination. That is a Williamson's ether synthesis. In this, that is the preparation of the ether. Means when the alkyl halide is going to be treated with the sodium or potassium alkoxide. It is going to be formed an ether. In this, if you are going to be taken, suppose that is the Williamson's ether synthesis. I said that alkyl halide. That is alkyl halide we are going to represent by Rx. That is alkyl halide. Alkyl halide is going to be treated with the sodium or potassium sodium or potassium alkoxide. Sodium or potassium alkoxide. If you are going to be taken that NaOR, we are going to be sodium alkoxide. This is the name of this, we call it as a sodium alkoxide. Sodium alkoxide. It is going to be formed an ether. It is going to be formed an ether. That is going to be ROR plus NaX. Here, that is ether is going to be formed by this method. In this method, that is in the Williamson's ether system, both that is the symmetrical ethers and the unsymmetrical ethers, the both are is going to be prepared by using this method, that is Williamson's ether synthesis. For example, if you are going to be taken some example for this Williamson's ether synthesis, if you are going to be taken that alkyl halide, you can take the ethyl bromide, that is ethyl bromide, that is C2H5Br. Ethyl chloride you can take, that is next it's treated with the sodium ethoxide. Sodium ethoxide, that is C2H5. NaOC2H5, this we call as a sodium ethoxide. It is going to be formed that diethyl ether. Diethyl ether, C2H5O C2H5. This we call as a diethyl ether plus then NaBr. That is sodium bromide. There is ethyl bromide. Alkyl halide to be example, that is ethyl bromide. Ethyl bromide is going to be treated with the sodium ethoxide. The name of this is sodium ethoxide. Then it's going to be formed that an ether, that is diethyl. This is example for the symmetrical ether. Symmetrical. Like that only we will take the for example that is unsymmetrical ether. If you are going to take that unsymmetrical ether, that is C2H5Br. If you are going to be taken this, then instead of sodium methoxide, you can take sodium methoxide. That is CH3. That is this is the ethyl bromide. Then the sodium methoxide. Is going to be undergoes a reaction. It's going to be formed that is the ethyl methyl ether. That is the ethyl methyl ether. That is we call as a ethyl methyl ether is going to be formed. Ethyl methyl ether is going to be formed. This about the Williamson's ether synthesis. By using this Williamson's ether synthesis, both that is a symmetrical ether and unsymmetrical ether, both we can be prepared. This about the that is two methods of that is a preparation of these that is ethers by the dehydration of alcohols and by using the Williamson's ether synthesis. Williamson's ether synthesis, we prepared that diethyl ether, and also we are prepared that is ethyl methyl ether. That is symmetrical ethers and the unsymmetrical ethers, both are we have prepared Williamson's ether synthesis. This method is applicable only for the primary alkyl halide. It is just adapted for the primary alkyl halide. Because if we are using the secondary alkyl halide or tertiary alkyl halide, instead of that is formation of ether, it is going to be formed. It undergoes the elimination reaction. Therefore, it it is adopted only primary alkyl halide. We will check it out once. That is, if you are going to be taken, suppose instead of primary alkyl halide, we are going to be taken the tertiary alkyl halide. That is tertiary butyl bromide. If you are going to be taken the tertiary butyl bromide, this is going to be reacts with the that is sodium alkoxide NaOC2H5. NaOC2H5. At that time, this undergoes the elimination reaction. This undergoes the elimination reaction, which is going to be formed that is a CH3 C double bond CH2 then CH. That is a 2-methyl propene is going to be formed. That is NaBr plus C2H5OH. This means in this it undergoes the elimination. It undergoes the elimination reaction. Therefore, to avoid this, in the formation of tertiary or secondary, that is like ethers is going to be prepared. Instead of using tertiary group with the halide, we are going to be taken with the that is sodium. That is it is going to be, suppose it is going to be taken, that is instead of this we are going to be taken that C2H5 Br. This primary alkyl halide is going to be treated with the sodium, that is butoxide. That is sodium butoxide. If you are going to be taken with the treated with the, that is ethyl bromide. The ethyl bromide is treated with the, that is sodium butoxide. Tertiary sodium tertiary butoxide. At that time, it's going to be formed an ether. It's going to be formed an ether. C2H5O C CH3 CH3 CH. That is ether tertiary butoxide is going to be formed. Tertiary is going to be, ether is going to be formed. That is tertiary. That is going to be formed. That is the name of this compound is ethyl tertiary butyl ether. Ethyl tertiary butyl ether is going to be formed plus NaBr. Means the tertiary butyl ether is going to be prepared by using this reagents, that is the sodium tertiary butoxide and the ethyl bromide. If you are going to be taken the tertiary that is alkyl halide, means we are not getting the ether. Instead of this undergoes the elimination reaction. Thus you should be keep in mind that is the Williamson's ether synthesis. It is adopted for the primary alkyl halides. If suppose instead of the primary alkyl halides you are using the secondary and tertiary, means it undergoes the elimination reactions. Now we are going to be discussing about the preparation of phenolic ethers.